Today we're going to be walking through a 101 lesson. I'm going to be talking about something called tokenization, which is a concept fundamental to how large language models work, but it's one that a lot of people don't really have a good grasp on. So I wanted to just cover the basics and show why this is such an important topic, why it's important to know about it, and also how it explains some of the problems that we have with modern large language models. Tokenization. Tokens are the little units of how large language models work. This is the most important thing here. So every large language model basically has a large database which is full of vectors, which are words or chunks of words or pieces of sentences. And I'm going to show you a live demonstration very shortly inside of this big database with relationships between these different tokens, not words. I'm going to be very careful here. So it is the small unit that on which all of the large language models, so things like GPT 5.5, Opus 4.8 is the most modern one from Claude, they all run on these tokens. They're not exactly words, but words are a good enough kind of proxy that we can use them relatively interchangeable. It's not accurate, but it is relatively close enough for everyday usage. In general, one token is about 3/4 of an English word. What I'm actually going to show you, because it's much easier to show you this, is I'm going to show you something called Tick Tokenizer, terrible name or great name, I'm not sure, where we can put in a prompt and it will break up that sentence into tokens. So this allows us to see what tokens actually are. So let's use, I'm currently doing a live stream about tokenization. So that is the sentence. So that consists of 1, 2, 3, 4, 5, 6, 7 words, or maybe 8 words if you think the contraction I'm is an additional word, but it turns into 15 tokens. Now, on the right-hand side, you can see these colored breakdown of what the particular tokens are. So, for example, this is a useful one. The word tokenization is not one token. It's actually 2. The first token is this token, and the second one is ization. So this is how the large language model has broken this down. It's chunked up the English language into these particular tokens. I'm is a token in and of itself. That's one token. Currently is a token. Doing is a token. A is a token. Live stream is a token. About is a token. Tokenization is not a token. It's 2 tokens. Let's do some more in here to help people understand the concept a little better. Let's see which other ones are broken up. Trying to look for some interesting ones. It's very tricky for me to know what the exact tokens are. So I'm trying to look for one that is broken up. So I'm just going to keep typing. So I'll just keep typing until we find an example that is useful. So in the case of tokenization, for example, that is 2 tokens. So I just want to show that a token is not always a word, although in this particular demonstration, it was coming out as a token equals a word quite a lot of the time. But I recommend you go onto Tick Tokenizer and you can actually plug in your own sentences, plug in your own inputs and see what comes out of it. There is also an official tokenizer from OpenAI. So if you go to platform.openai.com/tokenize, we can do the same thing. I am looking to show some examples of how a word is not necessarily a token. Let's see if we get any better ones. That is fascinating and very annoying for my demonstration. Go and try these out yourself, because what I wanted to show is that a token is not a word, but we are currently getting a one-to-one. For the most part, we are getting a one-to-one relationship, which is very annoying for the demonstration. I should have prepared some other ones. As a rule of thumb, and this is the official rule of thumb from OpenAI, one token is generally 3/4 of a word if you average over the whole of the English language. And everything that we put inside of a large language model, so all of our inputs, all of the documents, all of the images that we give to it, everything is reduced into tokens. And if we actually look at the tokenizer here, we can see that each of these tokens has an ID. So for example, the token currently has the ID 6821. So that is the ID of that token inside of the GPT-5 models, for example. That's actually different in the GPT-4 models. The token for that would be 5 3131, and in the GPT-3 models, the token is actually 3058. These are arbitrary. There's no particular connection with the meaning of that word or that token. But these are what are stored inside of the large language model, with these numbers basically. And then the relationship between all of these numbers is worked out in order to help us then generate probable answers when we get an output from a large language model. So you're starting to see inside of the large language model when you play around with tokenizer like this. I think this is just a nice surface level dip into how these things are working under the hood. So tokens are generally words. You can use word and token interchangeably. It is not accurate. It's about 3/4 rather than a full word. However, for the most part, it is relatively simple to think of it as a token. However, if you are using different languages, not all languages are equal. So English is one of the most token efficient languages inside the large language models, which explains also why we use English for the most part. It's also because there's a lot of training data, so you can train the models on English. But this is actually a larger problem if you want to use artificial intelligence and you are working in a different language. The reason is your token input and your token output is a lot heavier in other languages. Somebody actually worked it out. So putting in the text, what will the weather be next week? It uses 7 tokens in English, 8 tokens in Spanish. Korean, it goes up to 12. Burmese, it goes to 61. So it's almost 10 times as much. And Amharic goes up to 69, so 10 times as much. So if you are working in other languages and not English, you actually end up generally using a lot more tokens than you would if you work in English, which is a big problem in terms of accessibility and making sure that AI is adopted everywhere. If we write it in Chinese, woman, nung kan dao, sorry, kan dao qibia. There we go. So if we write in Chinese, we can see a difference. So as you can see on this tokenizer here, each of these characters is 1 token, so it's very tidy inside of Chinese. The exceptions here are these words here, so kan dao, which is in and of itself a word, and qibia, difference, which is in and of itself a word. So it's very neat and tidy in Chinese compared to English. Anyway, we don't particularly need to know all of the different languages and how they tokenize. We just need to understand that it is roughly a word, but not always. So how tokenization works, you're going to type in a text, and you can play around on TikTok Tokenizer or the tokenizer from OpenAI. A tokenizer is going to chunk it. It's going to split that sentence up into its constituent tokens. The model then processes the token IDs. So if we go in here, these ID numbers are the IDs connected to these particular Chinese characters. So this first one here, is 57980, for example. So the model is going to use that in its calculations in the next step. And then off the back of this, the model is going to generate new tokens and then output those tokens as the answer that is given to you. So that is why tokenization is really important. Large language models are not working with words, they're working with tokens. This leads to the famous problem with raspberries. So humans, we see individual letters. Models do not see individual letters inside of a word. They're seeing the chunks inside of a word. So if we go ahead and we plug in raspberry, let's see what happens with raspberry. Oh, fascinating. There we go. So raspberry, this is a perfect example. Raspberry, which is 1 word in English, breaks up into 3 tokens inside of, this is GPT-5. So the first token is RAS, RAS, then followed by P, which is an individual token, which is a bit weird, and then berry, which is the 3rd token here. This is why we get the raspberry problem, because it is not seeing the whole word. Let's try with strawberry. Strawberry comes across as 1 token, whereas raspberry is split into 3 different tokens. Again, this is fairly arbitrary. This is just how the model has chunked it. And this is why we get the problem with raspberry. So this is the particular reason why we have the problem with raspberry, is because it is not seeing a word, it is seeing the individual tokens and it's chunking it up. And for whatever reason, raspberry is chunked in a very strange pattern, which means that it can't count the R's. This is why when people bring up the raspberry problem again and again and again, it suggests that they don't really understand how tokenization works, and they need to understand the fundamental mechanisms that large language models use before they get quite so upset about it. It's a very easy criticism to level at large language models, but there is a root cause. It's because there is not a database full of words, there's a database full of vectors, full of tokens. So why is this stuff important? What does this actually mean on a day-to-day basis? The reason I brought this topic up and I wanted to talk about it is because in my private WhatsApp group, somebody was asking about switching to the Claude 1 million model. And they were asking, what is this? Should I be doing this? Is this important? The 1 million refers to the number of tokens in the context window. So the context window of a model is basically its working memory. How much information you can put in, how much information it can process, and how much information it can put out in tokens. So 1 million tokens is a lot of tokens. Most models are around the 200, 300,000 token size, but the more recent models are all hitting 1 million. So GPT 5.4, Gemini 3.1 Pro, all of the new Gemini models, all of the Claude Opus models, they can all now go up to 1 million context. If you are using the API, or if you're using Claude Code, you can manually select it. This is important because it allows our model to deal with more. It's the total token budget available for the current task. This is not just your inputs, but it's also any documents you give it. It is any images, which are then converted into tokens. It is chat history. It's any tool. So if it goes off and does searches or researches for you, that is all going to be eating into your budget. And it's going to be the outputs as well, which use output tokens. So the larger your context window, the more working memory your chat has, and the more you can do within that chat. This is not the same as the long-term memory, which is separate. That is at the application level, where ChatGPT and Claude will take note of what it knows about you. And it's not the same as the training data. This is purely inside of a particular chat, inside of a particular session, the working memory that it has to work with. Now, what used to happen is, you probably remember this from a year or so ago, you would often reach the end of a chat and it would say, oh, we're done here. You cannot proceed with this chat, and you'd have to start a new chat in order to continue your work. The reason that happened was because the context window filled up and it no longer had any more working memory with which to work with you. So it would just say, okay, we're done. That rarely happens now because most of the models, especially the paid models, the pro models, the thinking models, they do something called context compaction, where they will look at everything that's come before and they will compact it down into a short summary, and then it will basically move that summary into a new chat, into a clear context window to work with you. So what it does is, let's say you've got a context window of 1 million tokens. Let's say you have, 100,000 left. At that point, the model is going to be like, oh shit, we're running out here. I'm going to use this remaining 100,000 or 200,000 or whatever it is. I'm going to use this to review everything we've gone through and to summarize it into a nice document, and then we're going to move it across. That now happens automatically. Previously, you just got kicked out of the chat. Very annoying. Now, at least, you have a chance to continue, but it is still compacting. So it is still losing context. It is not taking the million or the 200,000 tokens from the last chat into the next chat, because that would immediately fill up the new chat. Instead, what it is doing is creating a summary. So that means there's a potential for, when it does context compacting, for it to forget things, leave things out, which you might think is pertinent, but it has not flagged up as important. So you do need to still be careful. It's very slick, it's very automatic, you don't have to think about it, but it might be forgetting things that are going to be important because they were in a previous iteration, in a previous context window. The other thing with context window is that bigger is not necessarily better. A lot of people, when Claude released their 1 million context model, automatically switched. And then in that week, everybody was slamming into their limits immediately. And everyone's like, well, what the hell's going on? I thought we had a bigger context window. I thought you were giving us more to work with. It was just running through the tokens much, much faster, because when you are working with a large context window, a couple of things happen. One, you're more likely to throw more at it. So instead of taking a slice of a database that you want to work with, if you have a much larger context window, you're more likely to be like, fuck it, give it the whole thing, and it can deal with that, and it will be able to work with it. It can do that, but you're just going to be using more tokens. If you're on a something like Claude Code, you have a limit to the number of tokens that you can use. The other thing is, when you are throwing a huge amount of information at it, it's harder for the AI to find the pertinent information. So just because you can give it textbooks, just because you can give it the literature back catalogue of an academic subject, just because you can, does not mean that you should. It's going to mean that the signal that you're looking for is going to get lost amongst all of the noise. This is really important when you're doing something like using Notebook LM. With Notebook LM from Google, you can add a huge number of sources. You shouldn't, because as soon as you do that, it's very hard to get the actual pertinent information out because it is now looking for the useful stuff amongst a whole load of absolute nonsense that you've also given it. So you still have to be very selective. And then the third reason here is that the context memory management, or the context management, also uses tokens. So when you have a large context window, there are processes going on in the background, things like context compaction, but also looking up and finding the information which require more tokens to carry out. It's doing reasoning and thinking processes in the background in order to find that information. And that again is just eating into your tokens. So just because you can use a bigger window does not mean you should. So this matters less in chatbots. If you are using the app version, so you're going to chatgpt.com or claude.ai, or you're using the one on your phone, generally you cannot see the context window. So you can select if you want the standard model or the 1 million context window. But generally when you are just talking to a normal chat version, you're not actually seeing this. It's all in the background, but it is still there. You are still going to be running out of usage. You are going to be requiring context compacting. And it still means that if you throw a huge amount of stuff at it, just because you can, you're going to get worse results than if you selectively provide information to your artificial intelligence. So this is context management, giving it the right stuff. This matters a lot more, though, if you are using the API. So if you are building using artificial intelligence, then this is when you start to really pay attention. So let's look at, this is a new model, Gemini 3.1 Pro. I'm getting mixed up with the Flash model. Let's look up a model on artificial analysis. So let's go, I don't know, Opus 4.8. This is one that came out last Thursday. I see a lot of red numbers because it's very expensive. So there's a couple of things you can see here. When you are looking at an actual model, you can find the model specifications on the website, or you can come to a site like artificialanalysis.ai. A couple of things. You can see things like the output price and the input price. So the input price of Opus 4.8 is $6.25 per million tokens. It's expensive. That's really expensive. The output price is $25 per million tokens. It's currently ranking 125 out of 150. So it's one of the most expensive models. This is one reason why you need to know about tokens, because it's going to directly affect your cost when you are using the API. And you need to know what this means. What is 1 million tokens, and why is it costing me $6, and why is it costing me $25 on the output? There's other things here, like you can use artificial analysis to look up how many tokens there are. So the context window here in the technical specifications is 1 million, which is, it tells us here, about 1,500 A4 pages of Arial size 12. Very specific. So you can find the context window in here. Let's go speed, price, and context window. Here we go. Context window. This inside artificial analysis gives you a rundown of all the different context windows. But what we're really looking for is pricing. So pricing is going to be super important because you're paying per token. Therefore, this is how you can run up those obscenely high bills if you are using the API. So right now you can see the price. Wow, I didn't realize GPT 5.5, it's $30 on the output token. I'm using that right now, so I need to go and check that. That's something that I've built into a few of my applications. So I need to go and check my billing because that could be incredibly expensive. So this becomes very, very important when you're not using the chat interface, but when you are building with the API, because the pricing is tied to your tokens. You've probably heard of a concept called token maxing, which is basically companies saying to their staff members, their engineers, hey, we want you to spend as many tokens as possible and to push forward as much as possible. This is a new trend over the last few months, and one that I think is a bit dumb, because just doing more, having more activity, writing more lines of code, writing larger reports is not necessarily more productive. You're not actually getting anything more done. And as you know, with AIs, they can be incredibly verbose. But if nobody's going to read that report, if nobody's going to act on that report, who cares? Who cares if you've spent millions of tokens building this? So token maxing is something that is, I think, wrongfully it's become a trend recently, and it's incredibly wasteful. So yeah, in the API, it's going to matter because tokens affect the cost, input and output tokens. The latency is just slower running a much, much larger context model. And of course, your margin. So how much you are charging your customer versus how much you are paying for the API cost. And everything counts. So every system prompt, user prompt that's coming in from your user into the API, tool results, output count. So everything is going to be adding to your cost and onto your bill. So you have to be really careful. So your job here is not just going to be giving people access to the best model and giving them unfettered context window, because that's going to end up costing you an absolute fortune. So this is when we move from just using AI to actually building with AI. It becomes super important. So it's all complicated, very complicated, working out how much context a particular model has, because generally the context window will be a different size in the chatbot, a different size in the harness, so like Codex or Claude Code, and then a different size again inside of the API. Generally, you get the largest, these 1 million context windows inside of the API. They give you access to the most powerful version inside of the API, but that's because they're charging you per usage and they want you spending more money. So it kind of makes sense. Whereas generally you get the lowest context window version inside of the app. Even if you're paying, if you are using just the standard chatbot version of it, you are just going to get the smaller, more limited model. That's kind of the trade-off, but it is a lot cheaper. You're paying $20, $100 a month instead of potentially thousands using the API. So the best way to check the official context window size is via the official documents. So let's look up GPT 5.5 docs. Here we go. So it has the pricing. So $5 on the input, $30 on output. Here we go. And then we have a context window of 1,050,000, a max output of 128,000. That'll be in one chunk. So it has all of the information in here inside the official documentation. However, if you want to compare lots of them at the same time, then I recommend artificial analysis. Then you're going to look at context window here on the left-hand side, and then you can click through to these specific models. If we go and let's check out DeepSeek. So you can see DeepSeek a lot cheaper. This is $30 per a million tokens on GPT 5.5, whereas you're paying 28 cents on DeepSeek V4 Flash. And it's still very good. So you can see this is why the open source models are a problem for the closed source models. But then you can find all the information inside in the back end here. And this allows you to compare and contrast rather than having to go to each of the official documentations. Okay, so rules of thumb. We've covered a lot of stuff about tokens, what tokenization is, and why this matters. This stuff is all shifting all the time. Context windows get larger. Context management is changing over time, but I think there are still some useful rules of thumb for when this is out of date, which will be in a month or two. Use the smallest useful context. So if you are building, don't just think using the largest context and the best model is necessarily going to be the best way to give the result that you need to your team or your customer. It generally isn't. And your job is finding out how you can do the work you need to do with your application with the minimal amount of context window. You're just going to be saving a lot of money and the least intelligent model you can use as well, because it's going to be much cheaper. So if you can do something with DeepSeek V4 Flash, as we just saw, which is 20 cents per million tokens, if you can do a job just as well as with the GPT 5.5 model, which is $30 per a million tokens, then use DeepSeek. Give the model the right information, not all information. Just because you can give a whole database to a large context window model does not mean that you should. This will only get worse and worse and worse as our context windows get larger. Right now, a million is the kind of the standard for the large context. As this rises to 5-10 million in the future, then it will be even more tempting just to dump the entire code base or to dump everything we can into a context window. That will not necessarily give you better results. Starting a fresh chat when a thread gets bloated still works. So I know we have context compacting. That said, every time you compact your context, it is basically like taking a photocopy of a photocopy of a photocopy of a photocopy. There's going to be a degradation. So if there is a task where, depending on what the task is, where you do need fidelity, you do need it to be high quality, then sometimes it's better just to start a new chat rather than continue one thread that you've been using for the last couple of months. If you've been doing one task for a few months and it keeps compacting, try taking a summary of that task, ask your main thread, ask it, say, hey, I'm going to move this over to a new chat. Can you give me a summary of everything? Take that over to the new chat and see how it does with those instructions. It might be immediately better. If so, that's because you've got a lot of bloat inside of your context window. And then basically optimize for useful context, not maximum context. Just because you can does not mean you should use as much as you can, because it's going to be expensive and it's not necessarily going to be better. So hopefully that was useful, giving you a quick summary of what tokenization is, what tokens are, because they are the underlying unit of large language models. So they're important to understand if you want to know what's going on under the hood. I will do more technical deep dives into how these AIs actually work, trying to explain them in simple non-mathematical language, which is tricky. If you are looking for somebody who's very good at this, much better than me, check out Andrej Karpathy. So this is from zero to building up your knowledge of how AIs work. If you scroll down past these very beginner videos, I've got something I'm calling the Karpathy trilogy. So this is Andrej Karpathy. He's done a couple of videos. This first one's an hour. This second one is 3.5 hours. And then this one is 2 hours. But he goes through how these technologies work, how large language models work. And this guy co-created ChatGPT. He knows what he's doing. He has recently taken a job at Anthropic. So he knows what he's talking about, and he's paid very well for this. First one will be Introduction to Large Language Models. Awesome. Thank you, guys. I'm going to finish up for today. Make sure you are subscribed over at aiwithkyle.com. It's free. You can click on Join the Community up here, or there's a little email subscription box here. And if you do that, you'll get the email 3 times a week with the summary of the lives. Here's the last one I just did. It will be the edited YouTube video, and then the kind of a written summary of everything that I covered on the live, followed by any links. So for example, last week I talked about job disruption, and I also built a little tool, which is an AI job risk diagnostic, which looks like this, which is linked from the newsletter. So you can play around with that. And then also like the slide deck and anything else is all available in the newsletter a couple of days after the live stream. So make sure you signed up, aiwithkyle.com. It is free and hopefully useful. Fantastic. Thank you, guys.